Alright, hello viewers, welcome back. Today I'll be doing a chemistry video. So we're gonna talk a little bit about the masses of the elements. We don't really use their actual masses because atoms are really small and it will be really inconvenient to keep writing down their actual masses. So we instead use their relative masses. So basically that's just the mass of the element compared to the masses of the other elements. So I'm just going to start off with something called relative atomic mass, or AR if you like to call it that. So basically the AR is just a ratio of the average mass of an atom of an element divided by 1/12 times mass of the carbon-12 isotope. So why carbon and why carbon-12 isotope specifically? So basically carbon-12 isotope is basically the most abundant isotope of carbon. It's readily available. It's almost everywhere. So scientists just decided to use this to compare the masses of other atoms. So basically, the relative mass of carbon-12 isotope, or like we call it the AR of carbon, is just 12. So 1/12 of the mass of carbon-12 is basically just 1/12 times 12, which is 12 divided by 12, which is just 1. So if we take this into use right now, let's say we want to find the AR of hydrogen atom. We need to take a look at a periodic table. Hold on. Alright, so we have a periodic table here. From here we can see that the mass number of hydrogen is 1. So that's the average mass. So it's 1. So 1/12 carbon-12 of the mass of the carbon-12. So that will just give us 1/1, which in turn will give us 1. So the AR of hydrogen is just 1. Alright, let's try another one. Let's do AR of oxygen atom. So basically look at the mass number of oxygen, which is 16. So it's just 16 divided by 1/12 times 12, which will just give us 16/1, which is just 16. So there are no units for AR because it's just a ratio. Yeah. Let's do two more. Let's do sodium and calcium. So sodium's average mass is 23 and calcium's average mass is 40. So let's do 23 divided by 12, which will just give us 23. And the AR of calcium is 40 divided by 1/12 times 12, which is just 40. There you go. This is for AR. Okay, that's for relative atomic mass. So let's just say you're just trying to find the mass of molecules. Yeah, molecules. So then we won't use AR, we will use MR, or relative molecular mass. We call it MR. So basically it's just the same idea too. It's a ratio. Oh my god, I keep writing ration. Okay, it's a ratio of the average mass of the molecule divided by, same thing as just now, 1/12 of the mass of carbon-12 atom. Yeah. So yeah, basically we gotta find the average mass of the molecule first. So let's try the MR of oxygen gas. So for some elements, we don't use AR to find their mass, we use MR. So some examples are like hydrogen, oxygen, and chlorine, because they exist as diatomic elements. That means like molecules, they don't exist as like oxygen atom, exist as oxygen molecule. So the MR of O2 is actually just... So we know that one oxygen atom is just 16. So 2 would make us 16 times 2, which is 32. So it is 32 divided by 1 over 12 times 12, which will just give us 32 divided by 1, which is just 32. Alright, let's try another one. Let's do MR of chlorine. So chlorine's a little bit of a special case. Chlorine's average mass is 35.5. So 2 of these chlorine atoms will give us 35.5 times 2, which is just 71. So 71 divided by 1 over 12 times 12 equals to 71. So that's the MR. And then for let's just try one more example. Let's do glucose. Yeah, glucose. So glucose is C6H12NO6. So how in the world are we going to find this? Oh no. Wait, no, let's not do glucose. I'll save glucose till later. Yeah, that's the boss fight. Okay, let's do ammonia. So ammonia is basically just nitrogen plus free hydrogen. So nitrogen is 14 and hydrogen is 1, so free hydrogen will be free. So it's 14 plus free, which is 17 over 1, 12 times 12. So we just get 17. So the MR of ammonia is 17. Okay, so now we've got this, we can move on to what if you want to find the relative mass of compounds. So then we also use MR, but this time we call it relative formula mass. Okay, I keep spelling the words wrong. My apologies, my sincerest apologies. So basically, this is the same thing too. It's just a ratio of the average mass of compound divided by 1/12 the mass of carbon 12. So now let's try an example. Let's find the MR of... This one is only for compounds, ionic compounds, yeah? So let's find the MR of sodium chloride. So sodium by itself is just 23 and chlorine is 35.5. So 23 plus 35.5 is 58.5. Divided by 1/12 times 12. So we'll just get 58.5. I think you know where this is going now, yeah? So that's the MR of sodium chloride. Okay, let's try something a little bit harder. Let's try to find the MR of copper sulfate. Let's do hydrated copper sulfate. So this dot over here, just take it as a plus, yeah? So it's copper sulfate plus 5 molecules of water. So yeah, we move it here. So copper is... Where's the copper? Copper is 64. So it's 64 plus sulfur. Sulfur is 32. Plus 4 times 16 because one oxygen is 16. So this is for copper sulfate. And then for the water, it's just... Water's MR is 18, so it's just 5 times 18. So we divide this by 1/12 times 12. So we will end up getting 64 plus 32 plus 4 times 16, which is 160 plus 5 times 18, which is 90, divided by 1. So we'll end up getting 250. That's our answer. This is our answer. Alright, let's do a mix-up challenge. Let's try find the AR of iodine. Wait, no, not iodine. You can't do that. Potassium, yeah. Find the AR of potassium. So same thing as just now. Take a look here. Potassium has a mass number of 39, so it's just 39 over 1/12 times 12, which is just 39. Okay, now try to find the MR of iodine. Yeah, okay, so iodine by itself is 127. So as a molecule, it's just 254 divided by 1 over 12 times 12, which is just 254. Okay, now we go to glucose. Find the MR of glucose. So this one is just 6 times 12, because carbon by itself is 12, plus 12 times 1, plus 6 times 16, divided by 1 over 12 times 12. So we just have to work this out. That'll give me 180. That's the MR of glucose. Okay, let's do one last one for today. The MR of ferric nitrate. Ferric nitrate, yeah, let's do this. So for iron free, where is it? Pardon me, I have difficulty finding the elements. That's 56. So it's 56 plus 3 times nitrogen, which is, I think, 14. Yeah, it's 14 plus 3 times 16 divided by 1 over 12 times 12. And that'll give you 14 plus 3 times 16 is 62. 62 times 3 is 186. So 186 plus 56 will give you 242. So that is the MR of ferric nitrate. So that does it for today. I hope you understand how we calculate the relative masses of elements now.